This presentation is titled Identifying Taser Markings on Fabric Consistent with Being Created by a Cycling Taser and the Application of Infrared Photography to Locate Suspected Taser Probe Markings on a Police Officer's Uniform. Hi everybody, I'm John Palucci. I had a very dynamic 20-year career in the NYPD. The last 8 of those 20 years was spent as a supervisor in the Forensic Investigations Division. This presentation was inspired by a case that I worked, and most of you are familiar with this video. This is the 8 shots heard around the world.
Just got shots fired. Subject is down. He grabbed my taser.
He grabbed my taser. Could Walter Scott have been in possession of the taser? Here we can see an enhanced video, the taser tumbling behind Slager. You see this wire from the probes connecting the two of them. Taser tumbling behind Slager in a trajectory where it could have been thrown by Walter Scott. We had a young man from Canada that created this animation, sort of explain it a little bit better. Here we can see the taser tumbling behind Michael Slager. So right after the incident, Slager makes some statements to his supervisors. And here's one of them where he says, after a short struggle for the taser, the suspect was able to wrestle it away. The suspect then stood up and pointed the taser at Officer Slager. Officer Slager then drew his weapon as he was returning to the standing position and fired multiple times. Here's another statement to his lieutenant, essentially about the events that occurred prior to the shooting. Officer Slager then utilized his taser and discharged a cartridge at the suspect. So for those of you not familiar with the different ways a taser can function, one of them is to fire a cartridge. And within that cartridge, we have probes. They're 2 like fish hooks that would stick, barbs that are attached to wire that would stick into your subject. And if both barbs make a connection to the skin, then the electricity is going to cycle between those 2 probes. And if they don't, then the electricity is just going to cycle between the probes that are on the muzzle of the taser. So he fires one cartridge, and he did carry a spare cartridge with him. And he's able to put the second cartridge onto the taser and deploy it. He then uses the taser to drive stun, which is like a stun gun, the suspect 2 times, once on the side and once in the back. Okay, so the second way a taser can function is as a stun gun, where you just press the muzzle of it up against your subject and you activate the trigger and it will work as a stun gun. So he essentially accounts for 4 total activations. Now the taser has a chip with a data download in it. And the way it works is each event has a unique identifier. It gives you the time and the date, the event type, which is here a trigger activation, and the duration. If you just pull the trigger on a taser, it's going to cycle for 5 seconds. You can interrupt that cycle by putting the safety back on. So as per protocols, Slager would, in the morning before he starts his tour, test his taser. Here it is, just a quick 2 second, 3 second, 4 second, 1 second, 3 second. So he would just test the taser and shut it off, make sure that it works. Now we'll get down to April 4th, which is the date of this incident, where we have him testing the taser when he reports for duty that day. This is the first activation of the taser during this incident. It's at 9:52 and 00 seconds. The time on the taser was a little bit off. That's why you can see this final event is sync, where they synchronized the time on the taser. It had drifted a little bit. So, but what we do have accurate increments in between these events. So 9:52 and 00 seconds, the taser is activated. 13 seconds later, it's activated again. Now remember, it cycles for 5 seconds. Okay, so 13 seconds later is really 8 seconds after it stops cycling. Okay, so now 6 seconds after the second activation, it's activated the 3rd time. So 6 seconds is really 1 second after it stopped cycling. So he's working this taser right now. He's involved in trying to get compliance from a subject. And then 11 seconds later, it's activated again. Those are the 4 activations that he accounts for in his immediate statements to his supervisor without knowing anything about this download data. Then we have 29 seconds that elapse and it's activated again. And another 8 seconds later, the taser's activated again. Why is this happening? What happens is we have a ground fight. From the time Walter Scott flees to the time the first shot is fired is 1 minute and 45 seconds that elapses. I used to box, and 2 minutes can be an eternity for a 2-minute round. So 1 minute and 45 seconds of running and wrestling and losing your weapon. As you can see, we have 2 people on the ground. Walter Scott's got a green shirt. Mike Slager has a dark blue uniform shirt. This is moving from right to left on the ground. Here's some images being extracted from the video. You can see Walter Scott starting to gain control of the situation, green shirt on top of blue shirt. And they're on the ground fighting. So gathering data, could Walter Scott have been in possession of the taser? Well, his DNA is on the taser. This is what I call the battle of the biometrics. Fingerprints versus DNA. It's a classic battle, and especially back when we believed that a lot of fingerprint development techniques could be destructive to DNA. There was a choice that you had to make on the scene, which one you might decide to go for. So essentially, DNA versus fingerprints. Now, DNA can be secondary transfer as well. Also, we have a taser that's involved in some wrestling around on the ground. We have the muzzle of the taser being pressed up against Walter Scott. So the taser swab, apparently the muzzle area that would be in contact with Walter Scott during a drive stun event was not swabbed, but nonetheless, it's a mixture that experts argued back and forth as to who was the major contributor, but clearly both individuals were on the taser. As far as DNA, I believe latent print development, which was not attempted, could have been much more probative. It would actually put the taser in Walter Scott's hands. So that's the battle of the biometrics. Now, in gathering data, with bloodstain pattern analysis, garment history is a very important part of trying to do experiments where you would reconstruct something that occurred. So think about when you have a brand new pair of khakis and you spill a glass of wine or you spill a cup of coffee on it, and you think, man, there goes $60 or whatever. And you look down and lo and behold, the liquid has beaded off of the garment. That's because in the factory, they put a finish on it, right? And the finish is going to protect it. It's going to make it hydrophobic. It's not going to be very friendly to liquids and liquids absorbing into the garment. So the construction and the history are very essential. After about 8 laundry cycles, that finish is going to be gone. So if you spill the same wine or coffee on it again, this time you're out of luck, right? Garment history, the construction of the garment, the manufacture of the garment, all those things, the type of weave are very important. So what I did was I contacted the family and I got a uniform shirt that Slager used to alternate with the one he was wearing that day. So they had a remarkably similar history. They've been owned and worn for about the same amount of time. They've been washed about the same amount of times. So we have a very similar garment to the garment from that day. And here's his shirt from North Charleston Police Department. He never reported feeling an electric shock from the taser. So he was wearing a bulletproof vest. Could the vest mitigate or eradicate the effects of the taser? Well, let's sort of recreate some of this. I'm wearing a Kevlar vest here and getting zapped by Dr. Mark Kroll. Oops. It didn't have an effect on me. The next question, would a cycling taser leave marks on the garment when it's in full contact for the 5-second cycle? So we'll start by doing a 5-second cycle on the garment. You can see right here, this is counting down. That's your full 5 seconds on this garment. So a physical inspection, the dark color really obscures any chance of seeing damage unless it's massive damage. So I had used different types of backing for it, metal, Kevlar, all kinds of things when I did my experiments on it. But if you held the garment up to the light, you could see a pinhole in the area where the terminal was, the bottom terminal was in contact with the garment. Of course, a pinhole, if that's all you've got to go by, you can hold up a uniform shirt that's been worn by an active police officer and probably find pinholes all over it. Doesn't necessarily mean he was tased with a taser, right? So how do we bypass this dark colored dye and get a good look at the rest of the garment? Well, once again, with bloodstain pattern analysis, I use infrared photography. The shirt on the left and the shirt on the right are the same shirt. The one on the right was photographed within the infrared spectrum, right? And then a little bit of post-production in Photoshop, convert it to black and white. But here you can make out a little bit some of the blood stains, but of course, once the IR is applied, the blood absorbs the IR wavelengths and the dye will typically reflect them. So I can get a very good look at the garment without the dye obscuring it. Here's another shirt, same thing. Same thing with this black shirt. You can see all this blood staining here. You can't see it here. So my equipment, initially I had a Nikon D70 that I purchased. It had already been converted to infrared. It was, I'd estimated it to be around 695 nanometer range based on the magenta color of the images that it was capturing. I later purchased a Fuji X-D1 full spectrum camera, and I had filters for 695, 720, and 830 nanometers, so I could go up and down the spectrum, the IR spectrum a little bit. So the first thing I saw when I applied the taser to the uniform shirt and I took a photo with the IR camera was it does create two marks, and they're very similar in distance. Of course, that makes sense since the probes on the taser are a fixed distance from each other, right? Another thing I noticed, and this is why it's good to have a garment with a similar history, is that we have these markings over here from pen, right? This actually, you see this seam right here. This is a pen pocket, and there's a little opening at the top. So apparently Slager would not always retract the point of his pen when he puts it in the pocket. And we can see markings from the pen that we couldn't see on the uniform just because of its dark color. Also here we have some shading, possibly due to ink on the inside of the pocket, because you can see through a little bit. It does become a little bit translucent in these, taking these infrared photos. So here's the test garment, and we have two markings. They're approximately 3.5 centimeters apart. One's larger than the other one. The larger mark is on the bottom, and the larger mark is approximately 1 millimeter in diameter. So these are the characteristics of this particular activation of the taser, and I conducted many others to see if I could, continue these, finding these similarities, right? So here is that uniform shirt. This is the exemplar shirt. This is the right breast pocket. And I applied the taser to this area here. Of course, with the naked eye, we can't see anything. But once we use the infrared, we can see, once again, two markings. Right? This was only a 2-second activation. So we have two markings. They're approximately 3.3 centimeters apart. One's larger. The larger mark is approximately 0.8 millimeters, very similar to the 1 millimeter diameter. And the larger mark is on the bottom. Once again, larger mark is on the bottom. I did like over 100 variables that would include the material underneath, the test substrate, the duration of the taser cycle, 1 to 5 seconds, single ply, double ply, triple ply of the fabrics. I did shirts, pockets, seams, shimming of one probe of the taser to keep it off of the garment. So if the muzzle was cocked and both probes weren't in contact, I did near contact, about 1 inch above it while cycling, removing the taser while it's still arcing the taser and then applying it to the substrate, and wetting the substrate with salt water to simulate perspiration, to name a few. So here's some of my notes from that. You can see the backing would be a vest panel or a metal sifter or sifter with foil. wooden table. So these were all different. No backing at all, air. Here's 1.8 centimeter shim that was applied to the muzzle of the taser to keep one of the probes from contacting. So here's SW for salt water. We have once again 1, 2, 3, 4, 5 second durations contact. I used a white shirt again with salt water, sometimes dry, arcing prior to contact, and then arcing. So numerous variables were covered in these experiments. And what I would do is create a grid, and indicate the muzzle orientation, and have, for many of these experiments, 5 boxes, one for each duration, like 1 second, 2 second, 3 second, 4 second, 5 seconds. Okay. So here's some of these boxes. And this is SW for the salt water. This is on a pocket. Using the white shirt, once again, muzzle orientation. We'll talk about that a little bit later. And these are all these different variables, white shirt, different durations. So you can see 1 second, 2 second, 3 second, 4 second, 5 second. So part of the analysis is going to be contextual data, right? And photos of Officer Slager right after the incident. One of the things we can see here is a pen in his pocket, right? Would that have any effect on a cycling taser? So JP11, I had a pen in here, and I activated the taser. The taser actually did some damage to the pen, but we can see instead of just 2 marks, the electricity sort of skips over the pen, and it's really starting to create marks all the way in the 3.5 centimeter range between the 2 taser terminals. So it is different. We do have a different effect when the pen is in the pocket. We also have the back of the shirt. This is where the pen was. So the pen was actually stopping the electricity from going all the way through to the back, as we can see it occurs in these other activations, right? So why would the larger mark be on the bottom, right? I'm going to start trying to interpret some of this data. Well, I conferred with Dr. Mark Kroll, who's the biomedical engineering department at the University of Minnesota. What happens is the initial arc is formed at the negative terminal. So the electrons flow from the negative to the positive. The bottom terminal is the negative terminal. Transient current density is greater at the negative terminal. Okay, here's a little diagram of how that works. So here's our negative terminal, and we have a much higher concentration here, and then it begins to fan out as it works its way to the positive terminal. So that would be a reason why we'd have more intensity at the negative terminal, which would create a larger mark. So also the density of the marking appears to feather out around the mark and creates like a halo effect. This halo effect is a result of threads on the bottom of the fabric's weave being discolored from the exposure to the cycling taser. Right, so let's have a look at this halo effect. Right, see what I'm talking about? It's darker color in the middle. This halo effect. Here's the actual uniform shirt. Seeing the halo effect. But what is the halo effect? Right? As I said, if you look at the threads on the top of the weave, they don't appear to be affected. Right? The current seems to go towards the threads on the bottom of the weave. So why is that now? So electricity takes the path of least resistance, and the threads on the top of the weave are in direct contact with the taser terminal. The voids in the weave caused by the 3-dimensionality of the weave, right? We have over, under, over, under, over, under. This is a standard weave, right? So the electricity is going to flow towards the threads on the bottom of the weave. This is a very crude diagram of what I'm talking about, just to help illustrate it. Once again, this is a near contact. So I was 1 inch away from the shirt when I activated this. This also had a Kevlar vest underneath it when I did it, and it still does create these marks, right? One was full contact here, and one was near contact over here. So here's the muzzle of the taser, right? We have, these are the terminals right here. Here's your terminals. The outer measurement from the outside of the terminal to the outside of the terminal is approximately 4 centimeters, and the inside to the inside is approximately 3.35 centimeters. So after I got all this data, person I was working with, I said, do me a favor. I said, take the taser and make like an X, just sort of, have one activation, create one set of marks, and then turn it and create another set of marks. So I left the office, I returned, I took a photo of it, of the shirt. The first photo I took right away, I saw these 4 marks. So I called him up and I said, you made those marks over the left breast pocket of the shirt? He said, yes, I did. So now I'm confident that I'm ready to go look at the actual evidence shirt. When I examined the shirt, I wasn't allowed to touch it or move it in any way. They would manipulate it for me a little bit if I asked them to, but there wasn't a whole lot that I could do with the shirt. So here's a regular white light photo of the left breast pocket of the shirt, and here we are with infrared. And the first thing I see is these 2 marks right here. It's a logical location. If I'm a right-handed person and I punch a taser out, then I'm going to hit somebody in the left breast pocket. It's cocked on an angle, like if you hold a firearm at an angle, the top would be canted to the left if you're right-handed. And so this was logical that this was a result of the taser in many ways. So here's our suspected defects. Once again, we have the pen marks above the pocket, right? We have these 2 marks right here. What do we have? We have 2 marks. They're approximately 3.2 centimeters apart. Remember, it's worn during a fight. If the garment's stretched out, once it relaxes, then it can be a smaller distance, but we're not talking about anything more than a millimeter. One mark is larger. Larger mark is approximately a millimeter in diameter, and the larger mark is on the bottom. It's got all the characteristics that I discovered during my experiments. It's also got the halo effect. There was an indication that this garment had never been examined previously because there's a notebook in the right pocket. So after I did my analysis, the state then did their analysis 3 months later, and they used infrared photography as well. And with their photographs, you can also see these markings. And the pen marks, right? And also there's some round artifacts that make their way into the picture somehow. But here's our marks from the taser. Now, one thing here, this was a great photo. I don't know what wavelengths, what filters were being used, but the shirt is backlit, right? And if you're familiar with document examination, to use different wavelengths to get inks to reveal themselves as being different inks, right? So what do we have? The ink is now gone, right? So are the artifacts, those round artifacts. But what still remains are these 2 marks, indicating, so if there's any worry that this is from the ink of the pen, of course, could be a different pen, but this just makes us that much closer to confirming what we came out here to look at. So I wrote a preliminary report, which was turned over to the state, and in response to that, they did some microscopic analysis of the shirt, and they had also used a taser on an exemplar shirt, which was a brand new shirt that was purchased at the equipment store. So what we have here is that part of the results indicate that a taser drive stun cannot be excluded as a possible heat source, which has the potential to melt polyester fibers. So research is continuing on this project. I'm working with Eugene Lischio, who's going to do some SEM analyses of the garments that I've already applied the taser to, using all these different types of variables. And we're going to be looking at some of the melted fibers and other characteristics that we can observe microscopically using the SEM. Thanks very much for your time. I'm glad to take any questions now.